All right, what's up, guys? So now we're going to be dealing with the limit of a function, and we touched on the limit of a function a bit when we did the difference quotient, the limit as h goes to 0. But now we're going to be getting into more detail. So let's start off with a question here. What is the limit of the function f of x equals x squared as x approaches 3? Okay, so you probably aren't too sure of what I mean by here. So another way to rewrite this is what y value does y equal x squared, the function y equals x squared, approach as x approaches 3. Basically, these two questions are the same thing. Another way that you can write this question, you're going to start seeing this in the course a lot, is what is the limit as x approaches 3 of the function x squared? Okay, so all three of these things here mean the same thing. So what is the limit of the function f of x equals x squared as x approaches 3? What y value does y equals x squared approach as x approaches 3? Or we could write it, all of this in notation, in limit notation. So what's the limit as x approaches 3 of x squared? And the answer to this question, let's just draw y equals x squared. So that's just a parabola. So it'll look something like this. And when x is 3, what's the y value? The y value is 9 here, right? Because 3 squared is equal to 9. So what y value does y equals x squared approach as x approaches 3? Well, as x is approaching 3, okay, on the function, the y value is approaching 9 from both ways. So basically the limit as x goes to 3 of x squared is equal to 9. Okay, let's ask a very similar question. What is the limit of the function f of x equals x squared as x approaches 3 from the left or from the negative side? Okay, so we added this left negative side here. So the way that you would write this notation is the limit as x goes to 3 from the negative side of x squared. Okay, so if we let's redraw this parabola here. This is y equals x squared. Okay, and let's say this is 3, and at that point the y value is 9. So we're getting a little bit more specific here. So what is the limit of the function as x approaches 3 from the left side? What is the y value, or what's the y value approaching as x approaches 3 from the left or negative side? So we have to go left to right. So we're approaching this point from the left side, so right here. Okay? And the answer is it's still approaching 9. What if they ask you the same question, but from the right or positive side? Okay, so same question, except this part here will be from the right or positive side. Well, in notation terms, you would just write this as the limit as x approaches 3 from the right or positive side of x squared. And on the graph, you would approach 3 from the positive or the right side. So what y value is x squared approaching as we approach the x value of 3 from the right side, well, it's still approaching 9, right? So the answer to this question is also 9. And when you're approaching functions from one specific side, from the left side, we would put a negative here. From the right side, we would put a positive here. These here, they're called one-sided limits. Okay, and we'll go into more detail working with these kind of limits. But for now, just remember that that when a limit is approaching from one side, it's called a one-sided limit.